This is AP Chemistry Screencast 3.8. Let's find some oxidation states. This is the acetate anion. Now you might be tempted to immediately take carbon, look it up, and say it's plus or minus 4, but it can in fact be variable. Whereas hydrogen, in this case, not being a hydride and not being part of an individual molecule, is going to be plus 1. That gives us plus 3 since there's 3 of them. This is not a peroxide. It's part of actually a carboxylic acid functional group, and so this is going to be minus 2, giving us minus 4. We have a minus 1 charge overall, which is what you get when you just have these, right? Minus 4 plus 3. Therefore, the charge on carbon is 0. Here's a strange case where the charge will not be a whole integer. What's the charge of iron? Well, it's a polyvalent metal, so it could be a bunch of things, just like actually carbon, right? Even though carbon is not a polyvalent metal. But the oxygen is plain old oxide, so we're totaling up minus 8 since the oxides are minus 2. And so we have minus 8 on that side, and 3 times something has to equal positive 8. So the charge on iron is going to be 8/3. That's a typo, isn't it? Oxidation state of iron should be 8/3. I'll change that. Also notice that if you're really into extreme detail, you can people have researched and found out that 2 of them are plus 3 and 1 of them is plus 2, and that adds up to positive 8. But who would know that, right? I'm sure that's beyond the scope of AP. All right, so let's go ahead and do all these. Find the oxidation state of each atom or ion. Calcium is alone, so it's a metal, not an ion, therefore it's 0. Calcium fluoride, the fluorides are always minus 1, therefore calcium is plus 2. Calcium oxide, the oxide is minus 2, so the calcium is plus 2. Calcium hydride, and when you say hydride, that means each H is minus 1, therefore calcium is again plus 2. Sulfur dioxide, each oxygen is minus 2, so the sulfur must be plus 4. SO2 minus, okay, we're having 2 oxygens at minus 2, that's minus 4, and if this is plus 3, we're overall minus 1. Oxides are minus 2, that's minus 8, and it needs to be 2 minus. Notice the slight typo where this wrapped around to right there. We need to be 2 minus overall, so this better be plus 6. Here's a long one, but it's a common one, dichromate. Okay, minus 2 for each oxygen, that's minus 14. And if we make this plus 6, that'll make that plus 12 overall, so that we're minus 2 for the entire ion. Sulfur, I have it memorized. I know this is plus 1, plus 6, and minus 2, but here's how you'd figure it out. Always minus 2, so minus 8. Always plus 1, so we are minus 6. This must be plus 6. Just a molecule, so sulfur is 0. Here's another page, and some of these are redundant, but what the heck. Carbon dioxide, each oxide is minus 2, so we total up minus 4. Carbon must be plus 4 in this case. Let's guess where it goes next. Down here, I'm guessing. We already did this one, plus 1, plus 6, and minus 2. And I missed it. Let's check out this one. This is oxides, each at minus 2, so we're totaling up minus 6. This looks like an error. I would say nitrogen must be plus 6, right? Gotta be. 3 at minus 2, so that's an error. This should be plus 6. This is plus 1, plus 6, minus 2. And here's that one we saw before where if this totals up to, let's see, minus 6, each of these is plus 3. So plus 3 minus 2. This totals up, since it's minus 2, to minus 8. And then 3 times something equals positive 8, so 8/3 and minus 2. That is some self-testing on oxidation states.